Ever wondered why your program isn't running as smoothly as you'd like it to? Or why it's taking an eternity to process a simple function? Well, the answer might lie in the realm of time complexity. Welcome to CodeHub Nexus, where we unravel the mysteries of coding, one concept at a time. Today, we delve into the labyrinth of time complexity, a crucial concept that can make or break your program's efficiency. If you've ever found yourself staring at a blank console, waiting for your code to run, then understanding time complexity can be your game changer. Output. In the world of algorithms, time complexity measures the amount of computer time an algorithm needs to complete its task. In layman's terms, it's a way to estimate how long your code will take to run. The lower the time complexity, the faster your algorithm works. Imagine standing at the entrance of a maze. The time complexity is the number of steps you need to take to reach the end. The fewer steps you take, the quicker you'll get out of the maze. That's exactly how time complexity works in your code. Now, how does one calculate time complexity? It's simpler than you think. The most common method involves Big O notation. Big O describes the worst-case scenario of your algorithm, meaning the maximum time it could possibly take. It helps you identify the parts of your code that could slow down your program. For instance, if you have a loop in your code that runs in times, the time complexity would be ON. If you have a nested loop, it multiplies, making the time complexity ON squared. The aim is to keep the Big O as low as possible, optimizing your code for speed and efficiency. It's important to note that time complexity doesn't measure the actual time taken. Instead, it gives you a measure of growth, showing how the time taken increases as the input size increases. A lower time complexity means your code can handle larger inputs more efficiently. To summarize, time complexity is a theoretical measure that helps you estimate the efficiency of your code. It's calculated using Big O notation and helps you identify potential bottlenecks in your program. The ultimate goal is to have a lower time complexity, enabling your code to process larger inputs faster. Remember, the key to efficient coding lies not just in getting your code to work, but in getting it to work efficiently. And understanding time complexity is a significant step in that direction. So the next time your code is running slower than a sloth, take a look at your time complexity. It might just be the key to unlocking a world of swift and efficient coding. Thanks for tuning in to CodeHub Nexus.